Hello friends, my name is Harald. Today I will show you how to convert a gear blank into a change gear for my Weiler lathe. It should be a simple job, shouldn't it? However, not everything will go according to plan. The size of the gear requires the use of the Weiler 4-jaw chuck. I first clamp the jaw slightly. Since I'm using this chuck for the first time, I first check the face for axial runout. It doesn't look good. Four bolts and a few nuts make standoffs and form a reference plane. Plan A is to mark the nuts with paint and to face them off. This should create a perfectly flat and perpendicular contact plane. Then I mount the gear blank using the live center. The blank is centered with the help of a dead center clamped between the live center and the bore. Checking the axial runout looks terrible. This won't work. It turns out that the wheel is not sitting firmly on the standoffs and has lifted off despite the pressure applied from the tailstock side during the centering operation. I tried to tap the work into place with no success. So plan B, I use the nuts to apply pressure to the gear wheel and lift it slightly off the chuck. This achieves almost zero axial runout. Since I had previously observed errors in the concentricity between the bore and the pitch circle on gear blanks, I checked the concentricity of the outside circle. It looks acceptable, at least good enough for a change gear. With the help of a thread wire inserted between the teeth, I also check the concentricity of the pitch circle, at least approximately. After a small correction, the pitch circle is within plus minus 200ths of a millimeter. That's good enough. So, at long last, I can make some chips. I use a cheap Chinese boring bar to enlarge the existing hole to about 21 millimeters. The target value is just a hair over 22 millimeters. For the finishing cuts, I use a small, very sharp carbide boring bar. Now it's time for some precise measurements. This is a good opportunity to show off my beautiful micromark measuring gauges. Basically, these work like 3-point inside bore micrometers. First, I determine the inner diameter of one of the original change gears. That's 22.010 millimeters, which is my target diameter. The current bore diameter of the new change gear is 21.915 millimeters. This means that just under a tenth of a millimeter still needs to be removed. I feed in 5/100ths of a millimeter on the diameter using the cross feed dial. This gives me 21.970 millimeters, which is 5 microns above the theoretical value, pretty close. I intend to remove the remaining 4/100ths in 2 steps of 2/100ths of a millimeter each. For precision, the feed is adjusted with the help of the dial gauge touching the cross slide. At this point I have a little bit of a senior moment. Of course, the dial gauge shows the feed as the radius, not as a diameter. Consequently, I already get the final diameter after the first pass, plus 8 microns oversize. If this would be a bearing seat, the part would go straight to the scrap bin. But it's still acceptable for a change gear. Phew, that was close. In any case, the bushing fits very well and without noticeable play. I chamfer the side of the bore facing the chuck somewhat adventurously with a boring bar. Hard to show, but you get the idea. On the opposite side, it's a little easier. That concludes the lathe work. All that remains to do is to cut the keyway, for which I will use the quill of my milling machine as a slotting head. Previously I used a cutting tool made from high-speed steel. However, it would be too embarrassing to show this quick and dirty ground thing of ugliness on video. So I grind a brand new slotting tool from a carbide blank. To keep the video short, I will show just a few short clips of this operation. The tool looks perfect, but it isn't, as we will see very soon. With the help of a high-speed steel blank, the cutting edge of the slotting tool is aligned perpendicular to the x-axis of the milling machine. The spindle is clamped. To align the slotting tool, I blacken the inside of the bore and slowly feed in the x-axis until I see a fine scratch mark. Since the tool apparently only scratches on the right side, I move the milling head a little bit to the left and scratch again. Now I also see a fine mark on the left. To double check, I blacken the bore again and scratch. The left mark is slightly stronger than the right one, so I move the milling head back a little to the right. The final check looks good. So now I can finally start slotting. The feed between each stroke is approximately 3 to 4 hundredths of a millimeter. At first this works well until I feel stronger resistance and notice a very rough surface of the keyway. Well, that's what is left of my shiny slotting tool. So I'm using the ugly high-speed steel tool which worked well on previously made change gears. No, I won't show it, it's too embarrassing. Done, and it fits. So, after a few trials and errors, I now have another gear wheel for my Weiler lathe. I hope the video was interesting despite the simplicity of the work involved. As always, I look forward to your comments and subscriptions. Thank you for watching and see you in the next video.